Welcome to Ando's Key Lectures. The topic is Center of Gravity and Centroid of an Area. Teacher Anand Mohandas. Key concepts for bodies. Mass is a measure of amount of matter in a substance or body. And density is a measure of the amount of matter therein per unit volume. So density is mass divided by volume. So mass equal to density divided by volume. Weight of a body is the force exerted due to gravitational attraction on the mass. So weight is mass into acceleration due to gravity. Now let's look at a set of forces that acts on a body. W1, W2, W3, W4, the forces acting on a body. Now they give rise to a resultant force or momentum or combination of both. And we resolve the forces and moment in directions x, y and z. So total weight equal to sum of all the forces, which is equal to W1 plus W2 plus W3 plus W4. That is total resultant weight. Now we know the total resultant weight, and center of gravity is the point where resultant weight of the body is focused. It means center of gravity is a point which may or may not be within the body, but the total weight of the body may be considered to act as a single force. There is the formula to calculate center of gravity is we take the sum of its moment divided by the overall weight of the object. So Cg equal to W1 d1 plus W2 d2 plus W3 d2 etc. divided by the total weight. So we calculate the sum of its moments divided by total weight. Now let's look at a problem. A rod of length 20 meter, mass 100 kg and 25 kg mass at the left end. What is the center of gravity related to the left hand? So we convert mass into weight force. So W1 equal to 100 into 9.8 and W2 is 25 into 9.8. And we calculate the center of gravity. We take momentum W1 d1 plus W1 d2 divided by total weight. So the answer we get. Now, centroid of an area. The centroid of an area can be thought of as the geometric center of that area. So here it's a rectangle. There is a dot which is the geometric center of that area. You find the x and y. Here we find the center of gravity along x and center of gravity along y. So along x it is b by 2, b is the base, and along y it's h by 2 for square rectangle. Similarly for triangle also. So let's see the centroid of some common shapes. So for a rectangle we have seen the area is b into h, and centroid along x-axis is half b, centroid along y is half h. You can easily understand from the diagrams. Similarly for a semicircle, the centroid along y is the 4r divided by 3 pi. And for triangle, centroid along y is equal to 1 by 3h. And for a quarter circle, you can see the area is 1 by 4 pi r squared. And centroid along x is 4r divided by 3 pi. And along y also it is 4r divided by 3 pi. So this is how we find the centroid of some common shapes. Here you can also see for the semicircle, the area is half pi r squared. Centroid along x is 0 and centroid along y is 4r divided by 3 pi. Now centroid of a rectangle with coordinates x and y coordinates, simple. The centroid is here in the example is the centroid is in the center of the rectangle at the coordinates 2 and 1. So x is 2 and y is 1 for the centroid. Now let us look at the general formula to find centroid of any shape. So the formula is total moment of area divided by total area. So A1 D1 into A2 D2 divided by area. And for example, there is a shape with rectangle and also half semicircle. So you add the centroid of rectangle with the centroid of half semicircle, and centroid of the given area from bottom left is what we are finding, which is equal to total moments divided by total area. So total moments in x direction we have to find divided by total area, which gives the centroid along x, and total moments in y direction divided by total area gives the centroid along y. Here we can see for rectangle, b by 2 is the distance and a1 is the area. So b by 2 and a1 plus, you are finding the moments. So plus b plus 4r by 3 pi. So this is how we find the centroid of any shape. Thank you for watching the video. Thank you.